Okay, so we'll start with the first week's tutorial. So as I said yesterday during the lectures, the idea of the course is that we learn some concepts, some theories during the lecture. In the afternoon, we discuss them a bit and like open up the topics. And on Tuesdays, like now, we get to practice like how to implement those ideas. So we basically make a map. The map that we make during these tutorials are not essentially the best maps you can make, but the focus is mostly like technical, how to make a map and like discuss how to make it better. But it's your job during the exercises to actually create a good map based on what we practiced today and what we have learned during the lecture. So that's the goal. Yeah, and as you already know, we have our tutorials and also the help sessions on Thursdays are in two parts. The first part is by me, where I teach you how to make maps with Python, open source libraries. And then after that, we have Tatu, who teaches you to make basically the same map, but with QGIS. So that's the structure of the day. So let's get started. So it's the first time we are doing this. Some of you are familiar with CSC Notebook. So you should go to the website and log in. So you can either log in with the CSC account if you already have an account, or you can log in using other methods like this Haka login that works as long as you come from a university in Finland. So I'm going to log in with my CSC account. So I have the application here already because of course I have created it, but for you, since this is the first time, you need to add the workspace to your CSC Notebook environment. And doing that is fairly easy. The information is on the course's webpage. I will just quickly show you. If you go to general information, I guess it's there. Yeah. So you need this code. So you need to just copy this one. So in general information at the bottom of the page, there's the join code for CSC Notebook. So you just copy that code and you go back to your notebook environment. Up here, there's a button where you can join workspace, this green button up here. If you just click on that button, there will be this pop-up where you can just paste the code you copied from the course's website and then add it to your workspace. I'm not going to click this plus button because I already have it there, but you should do it and then it should appear somewhere on your screen. In my case, I have this Cartogis 2024. So once you have it added, then just click on this power button to start a session. Depending on system situation, it might take a few seconds, sometimes up to a minute. It shouldn't take too long. So we also need another piece of information from the course's website. In my case, the CSC Notebook was fairly fast, so it's already opening. So I know many of you here and those watching the video later have worked with CSC Notebook before, for example in AutoGIS courses. But just a quick reminder, in my work, anything you save in this folder, my work, it will stay there next time you come. So whenever you just log in everything that you have saved in here, it will stay there. But if you leave anything outside this my work folder, the next time you open a session, it just wipes everything out, so it won't stay. And then shared is if there's a need to share something with you during the course, we will drop it into this shared folder, then all of you should have access to it. So in this case, now I'm going to get the tutorial materials from GitHub of the course. So just go inside the My Work folder. You clone it there so it stays there. Otherwise, as I said, it will disappear next time. So if you go back to the course's website, go under course environment. There is a link to a GitHub repository here for tutorials. So every week we update this. So every week there will be a new lesson added. Now we have stuff from the first week. So if you copied that link, then you can go back to the CSC notebook environment. We have a Git plugin here. So if you're more comfortable with like just terminal, you can just clone it using terminal, but we also have the plugin here, so you don't have to work with terminal. So clone a repository, then just paste the link you just copied from the course's website. You don't need to change anything else there, just click clone. And it should clone without any problem. It's a public repository, so it doesn't ask you for your Git username and password. So you don't need to even have an account on GitHub. So we just cloned the repository, we got the material, so it created a new folder for you called tutorial. So every time you pull the changes, more stuff will be added here. But for now you have the materials from week 1. So we are going to open week 1. So there are a bunch of files, some of which we worked with during our discussion yesterday, like the projection and everything. So we are not going to go through those anymore today, but we just put them there in case you want to use them. And there are some QGIS material that Tatu will go through later on. What we need for this Python tutorial is just this first file, this first notebook file. It's called Carto Intro Python. So this is the environment we will be working with during this course when we do things with Python. Okay, so now I guess I don't see any hands raised, so I assume everyone has managed to come this far. Yeah, so what we are going to do today, this is our first time during this course creating a map, so we don't have very big goals, but we have some important goals, but not very big goals yet. So we want to create a simple thematic map to just learn how things work, and then we will use what we learned during this practice to do our first exercise for the week. So that's the goal of this tutorial now. I will just show you how to create a simple thematic map and a bit work with colors and make things look a bit nicer. So we are working with a number of libraries today. So 3 libraries we use mainly today. One of them is the OSMNX. It's a library that is useful for getting data from OpenStreetMap. So we are going to retrieve network data from OpenStreetMap and just visualize it. So that's the data set we are using today for our tutorial. Then we are using Matplotlib, which is a powerful but simple library for creating visualizations, different kinds of visualizations, including maps. So it's not particularly for GIS or cartography, but you can also create maps with it. And then we are doing one thing that is newer. For those of you who have done AutoGIS course, you are probably familiar with the first 2 libraries, but we have not used PILO before, or PIL is Python Imaging Library. So it's a library for image processing. So you can think of it as something like Photoshop or other image processing software that we are familiar with. This is just a Python library that does many of the things we can do using those software. So yeah, so that's something we use. So even if you do not use some image processing software for creating your maps, you are kind of using it if you use a software like such as QGIS, because of course when you create a map, a part of that map creation is to do the GIS analysis, add the layers and assign colors and so on. But always at the end you have this graphic interface where you add things, you add your legend, you can move things around. So that is not particularly GIS, it's just a graphic interface added to this software. So yeah, so we achieved that today using this PILO library. It's a very large library, it does so many things, so I've put a link to the documentation. So depending on what you need for your work, you probably need to check out the documentation and see how things work. But we just have a quick demonstration of some small tasks for today. So yeah, so probably you remember for running code in Jupyter Lab, which is the environment we are using now, you just click on the cell, you then press shift enter, then it just executes that cell. So this is what we are going to do. Because the code is quite long for creating visualization, we do not really type in anything during this tutorial. All the code is already there. We just run the cells one by one, go through the process of what we are doing, and I explain what is happening in each step. So one thing that we follow during tutorials, the process is like we are kind of going through the process that any cartographer would go through. So you start by adding your data, you explore your data a little bit, then you make some map. Your first map is just to get an idea of what the data is about, and then we go through several steps to make better and better maps. So we are going to follow the same process. The first visualization we make is not necessarily a good map, but we try to improve it during our work. So I will go ahead and run the first cell, which is nothing but just importing the libraries that we need. So I'm importing some libraries, like pathlib is for handling the path to the files. The GeoPandas is for handling the geographic data. And then OSMNX that I explained. OS is, we use it later for like removing a file from our environment. Then we use some submodules from matplotlib for different things, and then we import Pillow and a few submodules from Pillow that allow us to do certain things that we will see later on today. So I will just run this, shift enter. Yeah, so the first one is done. So now we have the libraries loaded. Now we can continue with the rest of the work. So the second cell is just it's a good practice. We have talked about this a lot in the AutoGIS course. So if you don't remember, you can go check out that course webpage. But it's a good habit to use libraries such as this pathlib to take care of the directories, so the paths to the files and directories. So if you are using the same code, like for example, I wrote all these things on my computer, which is a Windows machine. Then I brought it here, which is a Linux machine, like the CSC environment. So to make sure that the file path works without any problem, it's good to use this pathlib library, and that's what I'm doing now. So yeah, so I create a folder here called my map, where I will save my final map at the end of this tutorial. So I will just run this, and it should create a new folder for you, a new directory called my map. And here I have passed in the parameter exist OK. It's just basically saying that if the directory already exists, it's OK, don't give me an error. So in our case, the directory wasn't there, so it was just created. So what we are going to do next is to get our data. As I said, we are going to use data from OpenStreetMap. So we are using this OSMNX library, which can easily get data from OSM through this function, graph from place. You can just provide the name of the place you want to get data from, and it will fetch all the data of that kind for you. So in our case, I want to get data from Kamppi, Helsinki, Finland. So you should be specific enough in the name. Think of it as like, well, it's OpenStreetMap. Think of it as Google Maps if you're more used to it. So if you want to search for a place, you should be specific enough in case there is another place called Kamppi in the world somewhere else. So that's why I added a bit more context, Kamppi, Helsinki, Finland, to make sure we get the right data here. So then we just provide the name. If you run this, it should get the graph object for you and store it in this variable called G. So let's just run this. Depending on how large the area is, it might take a few seconds. And this is comfy. If you had put the whole Finland or the whole Helsinki, it might have taken a few minutes. So in my case, it took less than 10 seconds. So we have the data now loaded into G, the variable name G. There is another function in this library that we are going to use that converts what we have here is a graph data. So it has the lines or edges and also has the intersections as points or nodes. So using this library, I'm going to extract edges and nodes. So it's what it returns is a tuple. So it just returns two values. So if you run this, it will store the edges or the lines of the road in this variable, and the intersections, which are points, will be stored in this variable. I've also added this edges.head, which is a useful GeoPandas function to take a quick look at our data. So this is what our data looks like. Some of you joined a bit later. If you have problems setting things up, just let me know. I can help you. So this is what I got from OpenStreetMap. Now I just use this .head to see what the data looks like. So you have a number of variables in your data. Depending on what OSM is crowdsourced, so there's no guarantee that the data will be complete, and depending on where the data is from, you might have some values missing, or the data might be very good in some places. Zoom out a bit so you see more. So these are the variables that we have in our data. So we have some ID fields. Then there is a field called one way that tells you if the road is one-way street or not. Then the number of lanes and the name of the place. And then there is a column called highway, which is a bit weird name, but what it stores is basically the type of the road. So it can be a highway or it can be other types. So, but the name is the highway. So the max speed and so on. So what we are going to visualize today in this tutorial are two columns. So we are going to visualize our data based on the type of the road, which is called highway here. So I want to visualize the pedestrian roads differently than the roads that are for cars. And I also want to visualize, add to my visualization, the length of the segments of the road. So this is just an example. In your work, you might be working with other variables, but now I'm just going to apply colors to our map based on the length of the segments of the road. So there's some more information about the columns and what they represent in OSM. This table comes from the documentation of OpenStreetMap, so you can just check it out if you need to work with it more. So now that we looked at our data, it helps to also have a visualization. After all, we are doing GIS, and without picture, without a map, it's hard to imagine what we are doing. So I'm going to run this next cell. So what it is basically doing is just using matplotlib to create a very quick visualization of what we have. So we import the library. You already know Python, so you know when you import library, you can also give it a nickname, so it makes your life a bit easier. You don't have to type everything every time. So I just give the name PLT to this library I just imported. Then I create my figure and I provide the size and the DPI I want to have for it. Later during this course, we are going to talk about DPI and resolution and these topics a bit more. And then I'm going to create my map. So I will plot the edges, which are the lines of the road. I will apply a color. In Matplotlib, there are a bunch of colors built in, so you just provide the name. So I have this saddle brown. You might want to put red or green or some other built-in color, and your map would look different in color. You provide the line width. In my case, I will just use 1, and alpha is the transparency level, so I will just go with 0.5. I will also add to my map the nodes, the points representing intersections. So I will add it to the same axe. I will apply a different color, line green. Marker size is 30. I guess it's a bit too big, so I'm going to change it to something smaller. I will go with 10 for marker size. And for the marker shape, I just have O here, which will just put a circle for you. You can put X or other shapes if you want the nodes to be visualized a bit differently. And then you can apply a color and line width and again transparency level for it. I'm going to set axis off because in Matplotlib you will get the X and Y axis. In our case with a map it usually doesn't make sense to have the axis, so I'm going to turn it off using this line of code. And if you want to add a title to your map, you can just use axe.setTitle. In my case, I'm just going to go with street network. You can assign a font size. I go with 15. And if you want to make it bold, you can say font weight bold. And then just run the cell. So very quick. So this is not a very beautiful map, but it is a very quick way of making a visualization based on our data using Matplotlib. So it's super fast. And you already get a sense of what your data looks like. So this is the street network from Kamppi area in Helsinki. The lines are the street segments, and then we have the points representing the intersections. So this is where we start from, and we want to try to make a bit better looking map during this tutorial. So we already saw that there are a number of built-in colors in Matplotlib. For example, green, or like you can just put their name. But if you want to have a wide range of colors, well, not everything is built in, so you need to provide more detailed specification of the color. And in our case, we are going to use the hex number, which is a way of representing colors. And we are going to talk about this next week during the lecture. So here I've written, let's just run this cell. It will give us this very easy tool. I just put it here to make our life a bit easier, but of course there are many of these tools online, so if you just Google the right words, you will get tools such as this one. So it just gives you can browse different colors, and it gives you the hex number, so you can use this hex number in your visualization to apply color to your maps. You can also choose how many colors you want in your palette here in Visualize. So you can use this one, or even better looking ones you can find online. Even Google has its own. If you just search, I guess there will be a tool. Yeah, so we will use this hex color codes to change the colors in our visualization. So yeah, so again, like I said many times already, we assume in this course that you have already done a bit of GIS with Python. So you have probably taken the AutoGIS course, and you remember from that course that we worked with Matplotlib. I can quickly open the courses webpage, the AutoGIS. So on week 5 we had this lesson on static maps, and we created different visualizations. So we have already seen, or we already know, that Matplotlib can automatically do many things. It can classify your data, it can create a legend automatically, and it has some default colors it can assign. So if you want to be lazy and just quickly create a visualization, Matplotlib has its ways. So you can just check Matplotlib documentation or the pages from AutoGIS course. For example, this legend is automatically created. So these are things you can do. But today we want to like even the legend you can automatically create with using Matplotlib. But what we are going to do today is to do things a bit more manually, so we have a bit more control over how things look like. Because if you have used Matplotlib before, probably there have been times that you haven't been happy with how things look, and it's just how it is in Matplotlib. So now we do things a bit differently. So I'm going to create lists to assign colors for each of the rows of my data. So in the first list, I create an empty list called row colors. So I'm going to assign colors to my rows of data. So each row of data is a segment of row on a map. So to each of them I want to assign a color based on the value of the length. So depending on how long that row segment is, I assign a color to it. So what I'm doing here is just using GeoPandas that you should be familiar with already. So I just write a for loop and I iterate through the rows of my data. And what I'm doing, I'm reading the value of length, which was one of the columns in my data. And I'm doing a classification manually. So if my road segment is less than 100 meters long, I'm going to assign this color to it. And if you want to see what color this is, you can just use this hex code. Just copy it and put it in this tool that we saw earlier. Just click on enter. So it's some shade of red. So if it is less than 100 meters, it will assign the color, this color to it. If it is 100 to 200, this other color, 400 to 800, 200 to 400, then 400 to 800, and then if it is any other value, I'm just going to assign white to it. So what it does, it just goes through each row, reads the length, and classifies it, and it stores a color accordingly. And here we are appending the color to this empty list we created. So what we are doing is quite simple. Going through each row of our data, do classification, apply a color, and store the color in a list. And since we are going through our data row by row, the order of the list will be the same as the order of our data. So it makes our life easy. So I'm doing the same thing for another column. In the highway column, some of the roads are footway. So it's just a keyword in OpenStreetMap. So it's a pedestrian road. So I do the same thing. I iterate through my data. If the type of road is a footway, I assign the line width 1. And if it is anything other than footway, if it is for cars, I'm going to make it a bit thicker on my map. So yesterday we talked about visual variables. Because we are using the color to show the length of the segment, we are using another visual variable, in our case the size, to represent the type of the road. In this case, showing whether it is a pedestrian road or a car, motorway. So I'm doing the same thing, going through each row of data, assigning value, and storing this value in this empty list I created called road width. I don't think I ran the cell. I do it now. I also run this cell, so it stores the values in this new list, road width. So if you're curious to see what has been stored in the list, you can just add a new cell and type in your own code and print the value of the list to see what you have inside. But essentially in this list we have the colors, in this list we have the values, 1 or 2.5. So next thing I'm going to do, I'm going to measure the extent of my data so that I can, like in QGIS or any software you use, you have mouse, you zoom in, you zoom out, you adjust the extents. Here you don't have that feature, so you have to manually get the extent of your data and then we specify it to, of course Matplotlib does it somewhat automatically, but again here we want to have a bit of control over how things are done. So what I'm going to do is to get the coordinates of the minimum maximum, so the 4 corners of my data. I'm using the nodes, you can also do it with the edges, for example. And I'm also adding a bit of margin later. So I don't want the map frame to end right where my data is ending. I want to add a bit of margin. And this value is a bit weird because it's in degrees, because the coordinate is in degrees. You're getting data from OSM. So if it was metric, we could have put just 100 meter or something, but it's in degrees. So I played this with this a bit before, and I know this looks good enough, but of course you can adjust it if you want. So I will run this cell, and now I have calculated the extent of my data, which I will use in my visualization. So now we are actually starting to create the map. We did some preparation, and now we will start to make a map that looks better than what we created already. Yeah, so there's detailed description of the parameters that are used in this next cell. I just briefly tell you what we have here, but there is detailed description on this page, so you can read it later. But what we are essentially doing, we are using Matplotlib. But Matplotlib is built in this OSMNX library, but the syntax is almost the same, so you could have done this directly from Matplotlib, but we are doing it through this OSMNX library. So I'm visualizing my graph. I specify the size. If you want a background color, you specify the background color. If you want a color for your nodes, I don't want to show the nodes, so I just put white. Then node size 0. So even the white doesn't matter, but I just put something there so you see how we can specify colors. But I don't want the nodes, the intersections, to be represented as a point. And then alpha is the transparency. We are not even visualizing the nodes, so it doesn't matter what you put here. I have put none. And then edge color, and yeah, these are about node that we are not visualizing. But for edge color, we have the road color. So this is the list we created earlier. So here you can pass in a list, as long as it's in the same order as your original data, you can pass in a list. We are doing the same thing for the line width, so we are passing in the road width list that we created earlier, and the rest is just adjusting the transparency and whether you want to save the image and the DPI and so on. We also provide the bounding box, which is the extent of our map we just calculated. So as you can see, that we have the north-south, the extents, plus the margin. The margin is that 0.001. So I'm adding a bit of margin to make the map look a bit nicer. Then what am I doing? So yeah, so next we are going to create our legend. So those of you who have worked with Matplotlib, you know that if the automatic Matplotlib legend doesn't look so nice, so we are going to do it a bit manually. So this way we can also specify like how things a bit look like. So I'm going to create a 2D line feature using Matplotlib. So this is how you do it. So each line represents one item in my legend. The marker is set to S, which is short for a square. You will see when we run this code how it looks like. So on the legend we have the color, well, we have the symbol as a square. There are different values you can assign. You can check them on the documentation of Matplotlib. And then I'm going to use, so I'm assigning different colors. So these are the same colors I put in this. Of course, you want the legend to be matching what you have on the map. So I'm using the same colors as I assigned to my segments of the road. So these are the same hex codes as we used before. And you add a bit of description to your legend item. So I'm just saying length smaller than 100 meters. So I'm repeating the same thing for all of them. And I'm also, so the font size and mark size we have defined up here. We just pass in the variable. So we do this for all of the classes we have in our data. And once you have created these legend elements, you can add it to your map like this. So ax.legend, then you pass in the legend elements and as the handle of your legend. And then here you can specify more things. Do you want a frame? I want a frame for my legend, so I've set it as true. Do you want it to be in one column or more? If you have like many items in your legend, you might want more columns, but in our case it will fit in one column, so I go with one. Do Do you want a face color for your legend? If you want, put a value. It's the background color of the legend, and then alpha is the transparency and the location. So this is one way of specifying the location. Just you can use it verbally, just saying upper left or upper right. It will automatically put it there. But I will show you later there is a more precise way of specifying where you want your legend to be placed. And then font size and properties. So in the properties, you can pass in the font you want to use for your visualization. So there are different things. So on my own computer, when I was running this, I had used the Georgia font, which looked a bit better. It's a matter of taste. But it doesn't work well here because, well, if you use a font, it has to be installed on the computer. And we are running this now on CSC Notebook, so not all the fonts are available. So if you run this with Georgia, you get an error that the machine Python cannot find the font. So either have to install it or you provide it from directly from internet. But now I'm going with a link that is safe, with a font that is safe, this serif font, which you can find usually on most computers. So this family can be any font as long as it's available on your machine, and the size, the font size you want to use. Yeah, so that's it. So one other thing we are adding here, we are adding a north arrow, and it might be a good idea in this case because we are not adding any base map. So for a person who doesn't know Compi so well, it might be a bit hard to orientate, so it's a bit difficult. So that's why I'm putting the north arrow. And since we visualized our math a bit more, I already have some idea where I want to put things. So because of the shape of my data, how Compi looks like, there is a bit of gap on the up left of my map. So that's why I'm putting my legend there. So it's a good place. I don't have to make my map bigger. So yeah, of course you can choose where you want to put your legend, but since you have some empty space there, it's a good place to put it. So that's why I put the legend to the up left, but you can try other values. And yeah, so I add the north arrow also here. So for doing that, there is a sub module in Matplotlib called Fancy Arrow Patch. So it has a number of built-in north arrow shapes that you can use. So I just use a simple one. Then you have to provide the exact location of where you want it to be located. And it's a bit complicated. It's not complicated, but you know, it's in coordinates. So you have to try a bit and find the right location for it. So I've done it already, and you apply a color to it, and that's it. And then you also add the text for your north arrow. So I add an N, and I apply a color to it and the font size, and then how you want it to be centered. And at the end, I'm going to save my figure using this fig.savefig as a PNG file. I specified the DPI and a number of other factors. So it's a PNG, so you also have the option of adding transparency. You know, with PNG files, you can have transparent background. So here you can choose to have it transparent as true or false. So it will affect what it is saved as, how it is saved. So I'm going to just run this cell. So it took a few seconds and it created our first map. So for those of you who have worked with Matplotlib before, you might already know that, okay, it looks slightly better than what Matplotlib would create automatically. So the legend is nicely located, the colors look decent, and yeah, so this is our first map. It's big, so it's hard to show it in here. But yeah, it's also saved here as map.png. So if you want to just download it and open it in your computer, you can do that. But yeah, that's our first map. So we have another cell which basically does the same thing. As I said, you can have even more control over the placement of your legend. So one easy way, just say upper left or upper right or something like that, or lower left, lower right. But if you want to exactly place your legend in a specific location, then you can provide an anchor value. And here I have put descriptions of how these anchor values are calculated or how they're defined. So if you put just anchor at 0, 0, it will place the anchor point at the bottom left of the figure for the axis. So 1, 0, 0 to 1, 1. Then you can imagine values in between will put your legend to different locations. So this again takes a bit of trial and error to see where the legend is located and whether it suits you. Here I put one example of how I am using these anchor values to place my legend. So like that. So if you just run this, it will give you the same output. So I'm just gonna run this cell. The rest of the code is the same. So this is just another way of placing your legend where you want, if you want more precision. So now we get to the a bit more interesting part of it, or the newer part of doing things. So we are going to do image processing. Some of you joined a bit later, and I mentioned already that very often, well, what you do in QGIS, you do your GIS, you add your layers, you add color. So that's the GIS part of creating a map. Then you have this layout window in QGIS. I'm using QGIS as an example because that's what we are used to most, maybe. Then you have this layout design, which is essentially not GIS anymore. It's just something like an image processing software. It's similar to Photoshop or something. So you just edit the image. You can drag, copy, paste elements. So it's not really GIS anymore. Since we are in Python environment and we cannot use that software, those features, we are going to use libraries. There are many libraries in Python that allow you to do image processing. So one of the biggest libraries for image processing in Python is this PILO library, PIL, or Python Image Processing. Yeah, so we are going to do that. So imagine this is whatever you would do with an image processing application, software. So imagine this is what you would do in Photoshop with your image. So what I'm going to do now, with Matplotlib, you can automatically assign a title and put it somewhere. Again, it has some features, but it may not look super good. So now we are going to add a title to our map. And it is kind of important for this map because probably this is the situation I'm going to use this for. I have maps of different neighborhoods in Helsinki and I'm showcasing them somewhere. So it's important to have a title to say that this map is from Kamppi. There might be another map from some other neighborhood. So title is kind of important to my map. And I'm going to add it at the bottom. It's a matter of taste and you can try different things, but we saw a few examples of layouts yesterday during lecture. But what I'm going to do is to add my title at the bottom of the map and to make it a bit stand out, because as I said, for me in this case, the title is kind of important. So I want to put a colored box with a bit more vivid color and then put the title there. So this is what I'm going to do. And this is something you cannot do easily with Matplotlib. That's why I'm using this PILO library. So what I have done here in this next cell of code, I've defined a library called add border. So I'm going to add some extra space at the bottom of my map, fill it with some color, and inside that box I'm going to put text. So let's first run this cell. Once you see the output, then it's maybe easier to explain what I'm doing here. So PILO, as I said earlier, it's a very large library, so probably you have to check the documentation. So let's also go ahead and run the next cell. That's where the output will be printed here. Then I will go back and explain what we have done. Okay, so this is now the map. So what we are trying to do is to add this title at the bottom of our map. So we have Kamppi, Helsinki in this red box. So this is what we are trying to achieve in these two cells. So I will go back and explain how I have done this. So I have defined a function for it. So yesterday we talked that one of the main motivations of doing cartography with Python is to automate things. And one good way of automating things is using, for example, object-oriented programming. Like, for example, in this case, we are using functions. So a function is easy if you have defined it nicely enough. you can reuse the same function. So if you're creating the same map for, I don't know, Helsinki, and a few other neighborhoods in Helsinki, a few neighborhoods in Helsinki, not just Compi, then you can just run this function and the same thing will be created. So that's why I'm showcasing how to do this way. So I define a function and it takes a number of parameters. The first one is the input image. So the image we are going to work with is a map that we had created already. Then the output image, where do you want to save the output map? And then some other values that I will explain. So fill is the color. So you have to pass in a hex color. The hex color code is the filling of the that box. So now we are going to use red according to my example. So I've put the hex code for that red color. And then if you want to add margin, so I'm putting the box at the bottom. So I'm adding a bit of a space at the bottom of my image. So I'm going to pass in some value for bottom. Here you can see 800. So I'm going to put 800, add a bit of extra space at the bottom of the map. So I've played with different numbers. 800 looks good for my image size. You can try it with different sizes and see how it looks like. If you wanted to add a box to the left, to the right, then you could have passed in values for left, right, top. But in this case, I just put 0. So what we are doing here is quite simple. It looks complicated, but it's a very simple thing. So what we are doing, we create a red image, which is the same size as our original map. It's just a bit longer at the bottom because we added that 800 units. So it's a bit longer. Then we are going to just paste it on my map. So my map is a bit smaller than what I just created in red. So the red part will stick out from the bottom. So that's what we're basically doing. So we just create a new image. We assign this fill color, which is red, the hex code here. You can try it in that tool to see what color it is. And then we are going to paste. We create a new image, then we just paste that image to what we had in our map. And then I'm saving the image as map.png, so it overrides what I had earlier. Then in this next cell, I'm going to open the image again and do a bit of work on it. So what I'm doing, I want to use the Pillow library again to write something. So it has just added that red box. Now I'm going to write something in that red box. So in Pillow, you have to create a draw object. And once you do that, then you can start editing the image. Then you can specify font, like what font are you using. Again, I had tried this with Arial font, and I got an error on CSC that the font wasn't found. That's why I went with the default. So if you just go with default, it will use something that it works. But of course, if you're doing this in your own computer, you have control over things. You have fonts installed, so you can use whatever font you want. And then you specify the size. And the text, I'm just writing Compi Helsinki. And again, you have to provide where the text will be located. And with trial and error, I got it to the right place. And then I'm saving it. In order to display the image here, I'm going to resize it because the image we produce is very large. It's good enough to be printed on paper. But here for Jupyter Lab environment, it wouldn't have fitted nicely if I had put the full size thing. That's why I'm resizing it. But of course, you have experience with this. With images, if you don't want them to get messed up when you resize, you have to respect the aspect ratio. So if you just adjust the height without adjusting the width in the same proportion, then the image gets messed up. So that's what we are trying to avoid here. So I want to assign a new width for my output map, so it's 600. But in order to respect that aspect ratio, I'm measuring the aspect ratio of my map. So I'm with image img.width. It's a thing coming from Pillow library. With img.width, I get the width. With img.height, I get the height, and then of course the division of them gives me the aspect ratio. And then when I'm resizing my map, my image, I'm making sure that the aspect ratio stays the same with this new width. And this is what I get as the output. So your background became white, and the reason for that is that we had transparency on. So with transparency, things look a bit different depending on how you open it. You might have even experienced it on your computer. If you have a transparent image and you copy and paste it, for example, to PowerPoint, sometimes the background might look a bit different depending on how it is processed. But if you want to look at dark here, you can go back and set the transparency to off. It was on, so I got this as an output. But yeah, this is the map we made. So this is the process. As you see, it's not as straightforward as in QGIS, but once you do it, you can just repeat it as many times as you want. The code is there. This is just mainly the goal here was to show you how to do things, but this is a decent looking map, but there are a few issues with it, and this is something you will be working on in your exercise. You won't be working with the same data, but hopefully we take something away from this and we avoid those mistakes in our exercise. So one of the things that is not good here, well, some elements are missing. For example, in this case, I think scale bar would have been good because we don't know how big the compy area is, especially if someone is not familiar. So it's a bit hard to know. It would have been a good addition, and this is something that we will learn to add next week. So we will get back to this. Then colors look nice, and next week Tuli is going to talk about colors and color harmony and so on. So these colors are very nice and harmonious, these colors we have used in our map, but they're not accessible for colorblind people. So we have both green and red in our map. So if we have any colorblind people looking at our map, they will be in trouble. So this is something we didn't pay attention to. So if you want to improve this map, of course you can go up, change the hex codes, use other colors that are accessible. So this is not the best example of a map in terms of the colors we chose. So this is something you can improve. Another problem that can be improved in your own work is data classification. So as you can see in our map, there are a lot of segments that are small. So they fall into this under 100 meter. So you don't get so much out of this map because there are a lot of rows inside the first category. So what I would do differently if I'm doing this in my exercise is to do the categorization a bit different. So I would put more classes. So I would go 0 to 50, 50 to 100, 100 to 200. So I would make the category a bit smaller so I would get more out. Or I might even use some other algorithm for creating the classification. So this is another thing you can improve in this map. And then one last thing. Yeah, another thing. Well, in this case, the colors look nice and we only have few classes, so it's not a big problem maybe. But one thing that you should normally think about, well, in here we have some kind of hierarchy. So like the length in that, if you look at the legend, the length, there's a hierarchy here. So a line that is 400 to 800 meters longer than the upper one. So in your colors, you usually want to have some kind of hierarchy. So it's not intuitive that blue is a longer segment than red. Unless you look at the legend, you cannot just intuitively know that this is the case. It works fine when we have only few classes, but imagine if you had 10 classes, then you had to constantly look at the legend to know what is what. So this is another thing that we can improve when we are doing our maps. For example, in our exercise, in our work, to use better colors. So if there is hierarchy in our data, they're a bit more intuitive. Yeah, so that was the tutorial. Hopefully this is clear. I have recorded the tutorial, so you can of course go back and check. And of course you have access to the code. You can a bit play with it, see how things work, what happens to the map if you change some parameters. And if you have questions, you can ask me now or later on Discord or wherever you find me. And just quickly on the exercise that you will do for next week. So the exercise is a bit, we have freedom. So the idea is that we haven't had so many lectures yet. We just learned some basics and we did one simple map. So idea is that, okay, let's use whatever we know from our previous courses and what we learned during this week and create a thematic map. So we will build our own thematic map. You can choose what data you want to use. So there are a few suggestions where you can get the data from Helsinki, InfoShare, PyToolie, other places. So you can get population density data, you can use with accessibility data, traffic data, so many other things. If you can't find good enough data, just write one of us and we will help you. But you can choose whatever data that interests you, create a thematic map. The focus is not on analysis, the focus is on making a nice looking map. So just get some data, population data, anything that interests you, and work on colors, where to put legend, how to work out the layout, and those things. So that's what we are doing for this week. And then we are going to discuss this next week. Actually, next week the discussion will be led by Tuuli Toivonen, and she's going to look at this map. So we are going to go through your maps and discuss how you have come up with certain decisions. Why did you use this color? Why did you put your legend here? So try to make decisions wisely and based on some justification. So yeah, so there's detail how to write the exercise, and it will be more or less the same every week. So here, the key points for your map: pay attention to the layout, your color choice, map elements, the projection. In this case, if you just go with data from Helsinki, it's not a big issue, but it's something to think about every week. And the aesthetics, think about how good your maps look like. And every week in your submission, I don't go through everything, but there are details of how the report should be. So half a page of text reflecting a bit on what we have learned during the week, what we have discussed. Then you just put your map and then just justify your choices. So tell us briefly why you chose this color or why you made this kind of layout, just so that we know how you have decided to do things. So this is and you don't need to submit code for Python. If you do this in Python, you don't need to submit the code. Just put the map and mention in your report that you have used Python to create the map. And just briefly describe what you have done. And that's it for tutorial 1 and exercise 1. And there is no help session this week because Thursday is a holiday, public holiday. So we will be a bit more active than usual on Discord. So if you have any problem, just write us and one of us will get back to you as quickly as possible.